Hello, it's the last online again, and we'll be discussing advanced mathematics, and they will be with me, Kimati, and the topic of today will be trigonometry, and the subtopic will be T formula, as most of the students do find some challenges in handling questions or in solving questions that involve the use of the T formula. So what we are going to do, we are going to try to remind ourselves on the T formula and on how we can solve different questions about that use T formula as a method. So be with me from the start to the end of the session. So we shall cover the following. First of all, we shall define what is the T formula, and then after that we shall try to remind ourselves on the T formulas, and we shall try to derive them and see how they are found, so that you can have a concrete understanding on that. And then after that, we shall try to use a T formula to solve different types of questions. And the types of equations that we'll be solving is the equation of that nature. A cos Q plus B cos Q is equal to C, whereby an A, B, and C are constants, while Q is an angle. Is an angle that we'll be looking for. Then after that, I will leave you some more questions for you to practice. So be with me so that we can understand each other. Definition. A T formula is any trigonometric formula expressed in a T, where T is claimed to be a tan of a given angle. I repeat that. A T formula is any trigonometric formula expressed in the T, where T is claimed to be a tan of a given angle. It's claimed to be tan of a given angle. And that is to say, T is equal to n over 2 x. T is equal to tan of nx over 2, where n is a member of all real numbers. Where n is a member of all real numbers. So sometimes there you can find a 4x or 4 theta, whatever. And x is an angle that we'll be talking about. Now we shall see how that is used. Now we can derive T formulas from any trigonometric formula, like a double angle formula. So you can use double angle formula to derive T formulas, or you can also use half angle formulas and other ways that can be used to derive T formula. I will use a certain method here to derive T formula, and just recognize what method I'll be using. You recognize if it's a half angle formula or it's a double angle formula. Please make a practice and understand what formula I'll be using. So these are the T formulas, and I will derive them shortly. We have for tan of x, we have 2t, tan of x is equal to 2t over 1 minus t square for tangent, and we have for sine, that is equal to sine x is equal to 2t over 2 plus for sine, we have sine x is equal to 2t over 1 plus t square. This is for sine. That means this is a T formula used for sine. And for cosine, we have 1 minus t square over 1 plus t square. That will be used for cosine. Now I will just try to show how these are obtained by a simple derivation here. Now, my dear students, suppose we have tan of A plus B. We know that this, as we discussed in a previous lesson, that this will be tan A plus tan B over 1 minus tan A tan B. So this is how this can be found. Now let's say we have tan of theta plus theta. That means we are talking about 2 theta. How will this be? It will be as follows. It will be tan of theta plus tan of theta over 1 minus tan theta tan theta. As we can see there, we have a tan plus tan. That means it will be 2 tan theta over 1 minus tan square theta. This is equal to tan 2 theta. This is tan 2 theta. This is tan 2 theta. Now, what if we have tan of theta alone? Now, this tan of theta can be written as tan of theta over 2 plus theta over 2. And we know that a half plus a half is equal to 1. That means a half of theta plus a half of theta is equal to tan of theta. Now, this, what is that? We can use that formula to find that. That means we shall be having, as we know, this is equal to that. That means we are going to have 2 tan of theta over 2 over 1 minus tan square of theta over 2. And this is tan theta as it is seen there. Now, let's do the following. Let t equals what? Tan of theta over 2. What are you going to have? What are you going to have? You will be having the following. You will be having the following. You will be having the following. That means in the place where we have tan of theta divided by 2, we are going to place a t. So all the places that we are going to we have tan theta over 2, we are going to place to replace that with a t. And that is to say tan of theta, how will it look like? Tan of theta is equal to what? Is equal to 2t over 1 minus t square. Over 1 minus t square. Over 1 minus t square. And that is to say, this is a half angle formula for, so that is to say that this is a t formula for tangent. This is a t formula for tangent. This is for tangent, a t formula for tangent. Now, we can use the triangle, a right-angled triangle, because we know that tan is equal to what? Is equal to the opposite over the adjacent. That means this is the value of the opposite in a right-angled triangle, and this one is equal to the adjacent of the right-angled triangle that has the angle theta. So how can we do that? For example, now we have a triangle like that, and this triangle has angle theta. We know that the opposite to that is this side, and the adjacent to that is this side. That means we have 2 over that thing, and we know that tan is opposite over adjacent. That means the opposite is 2 theta, and the adjacent is 1 minus t square. That is to say, my dear student, we can find the hypotenuse to that. We can find the hypotenuse to that. That is to say, if we call that is A, that is B, and that is C, and we know this will be side C, and this will be side B, and this will be side A to that angle. And that is to say, by Pythagoras, we know that is A square plus B square is equal to C square. Using Pythagoras theorem, we know that A is 1 minus t square, and all of that is squared, plus B is equal to 2t, and all of that is squared, is equal to C square. That is to say, if you open the brackets, that you are going to have 1 minus 2t square plus t raised to 4 plus 4t square, which equals to C square. Collecting like terms, we are going to have 1, and then we have a negative 2 square, and that is equal to plus 2t square plus t raised to 4 is equal to C square. Now, you will see that this can be a quadratic if we let t square is equal to another letter. For example, if our t square is equal to a, that means we are going to have the following: 2a plus a square equals to C square. if you try to look that much careful, this is a quadratic expression that has repeated factors. And that is to say, we are going to have 1 plus the factors t, 1 plus that is to say we are going to have 1 plus a, and all of that is repeating itself, is equal to c square. But what is a? That is to say 1 plus t square equals to, and all this is squared, is equal to that squared. But remember, we are looking at the value of c, not c square. That is to say we are going to find the square root on both sides, and we are left with 1 plus t square. That is to say, that part is equal to what? 1 plus t square. 1 plus t square. And then let's find the value of sine from that and the value of cosine. That is to say, sine of theta will be equal to what? And we know that sine is equal to opposite of a hypotenuse. And that is our opposite, and that is our hypotenuse. We're going to be left with 2t 1 plus t square. And what about cos? We know that that is adjacent of a hypotenuse, and that is 1 minus t square 1 plus t square. So these are the three formulas that are so-called T formulas that will be using them in different types of questions, and we'll use them to solve different kind of questions. And sometimes they are very useful while trying to integrate, when you do such kind of questions. Now let's see how they are used. Okay, now we have examples, and we are told use T formula in solving the question, the following questions, or the questions in solving the equations. Now, question number 1 says, show that 5 sine theta over 3 cos theta plus 4 sine theta is equal to 10t over 3 plus 8t minus 3t square, where t is equal to tan of a half of theta. But even if this part could not be shown, this part from that side, that means from that point to that, could not be shown, you understand that if the t are used there, then the T formula was used to get that expression of the right hand side. So the question can just end up there. Show this is equal to that, then you just understand that T formula was used. But also it is written like that. That means you know that clearly that you are going to use a T formula. That means you are supposed to understand what is the value of T, sine theta in T formula and cos in T formulas. So let's see how we can do that. That means from the left hand side, we are told that 5 sine theta over 3 cos theta plus 4 sine theta, then we are supposed to show is equal to what? To 10t 3 plus 8t minus 3 square, 3t square. So now it's a question that asks us to show. That means we are supposed to select a side that we are going to start with. Someone can start from the left hand side. That means can use the T formulas to find the right hand side, to manipulate the expression so as we can obtain the right hand side. But someone also can start from the right hand side, whatever, can start from the right hand side and manipulate to get this expression. But I don't think if it is very easy to manipulate that, but it's very possible too. I don't think it's very easy, but it's possible too. Okay, now let's, I will select the left hand side. From left hand side we have 5 sine theta and 3 cos theta plus 4 sine theta. I will use that side. But we know that sine of theta equals to what? Equals to 2t, as we did in the last part, over that thing. And the cos of theta equals to 1 minus t square 1 plus. I do hope you remember from your lessons from the class. That is to say, in the place of sine theta, we are going to replace that with this one. That is to say, we are going to be left with 5, and this is multiplied by 2 t 1 plus t square. And all of that is over 3 cos of that. That is to say, we are multiplying it with 1 minus t square 1 plus t square plus 4, and all of that is multiplied by sine. That is in that nature. Let's simplify this and see if we can get the other side of the equation that we are supposed to show. Now let's see. Then on top there, we're going to be left with 10t. All of that is over 1 plus t square. If you don't understand writing these lines, you can just say we divide with what? With 3, and all of that is multiplied by 1 minus t square over, but remember we have the brackets there, that is 1 plus t square plus all of that above there is multiplied by 4 and is over 1 plus t square. So let's simplify that once more, and we are going to have 10t 1 plus t square divided by, inside the brackets we're going to have, let's open that, it's 3 minus t square, and this is over 1 plus t square plus this one is equal to 8t 1 plus t square. As you can see, this and that do resemble. So how can we write that in a more simple form? Let's write that it will be equal to 10t 1 plus t square divided by this, adding to that, we're going to have 3, oh, sorry, there was 3t square. We're going to have 3 minus 3t square plus 8t, and all of that is over 1 plus t square. And if we go on with that, we're going to have 1 plus t square times 1 plus t square, and then we have 3 minus we can say plus 80t minus 3t square. So this and that goes, and then we are left with 10t, then we have 3 plus 80t minus 3t square. As you can see, the results that we have obtained there at the last point resembles the result that we have been given from the equation that said we are to show this is equal to that. That means we have to conclude as we did yesterday, as I did in the previous. So we have to conclude as I did in the previous lesson, as I said. Now we have to say, therefore, left hand side is equal to right hand side, and then we have 5 sine theta 3 cos theta plus 4 sine theta equals to 10t 3 plus 80t minus 3t square. So that's how we conclude our question. Remember to conclude. Remember to conclude. Now let's see the next example. How can we solve the next example? The next example tells us find the general solution in the equation, as I said earlier, that the equation of that nature, as I said, this 3, -2, and 1 are constants, and then x is an angle, and that is an equation of that format, or of that form, as I told you before. So we have been told to find the general solution in the equation of that nature, and the equation is 3 sine x minus 2 cos x equals to 1. So you have been given the equation like this, and you have been instructed to find the general solution to that. How can we do that? That means we are supposed to have the value of, or the formula, the T formula for sine x and the cos x, as we discussed earlier, and we can use those to find the general solution to that. Now let's go on. Now solution, we know that sine of x equals to what? Equals to 2t 1 plus t square, and cos of x equals to 1 minus t square 1 plus t square. That means we plug them there. So we are going to have 3, then sine, that is 2t over 1 plus t square, minus 2 cos, that is 1 minus t square 1 plus t square, equals to 1. Equals to 1. Now let's manipulate that. As you can see now, it is in t. It is in t throughout. Now let's do that. Then we're going to have this time, that is 3 times 2t, and all of that is over 1 plus t square. Don't open that with the negative just like that. Sometimes you can confuse. Just write it like that, minus t square and 1 plus t square. If you confuse those negative, I assure you, you won't get the right answer. Now let's do that. Let's add the fractions. That is to say, we're going to have a 6t minus 2, I've just multiplied by 2, minus t square minus 2t square. Now let's simplify that. We're going to have 3 times 2t minus 2, 1 minus t square, and all of this is over 1 plus t square, because this and that are the same, times 1. So if we simplify that more, we're going to have 6t, negative 2 times 1 is equal to negative 2. Negative 2 times negative t equals to plus 2t square, over 1 plus t square equals to 1. Now let's simplify that once more. So we are going to have that means I want to multiply that side. That means we are going to have a 6t minus 2 plus 2t square equals to, if you multiply 1 by that factor there, is 1 plus t square. Now after that, we can collect like terms, and there we have a positive t square, and that is t square. That means this coming to this side, that means you are going to have 2t square minus t square plus 6t minus 2 minus 1 equals to 0. That is to say, we are going to have 2 minus 1 is t square plus 6t. Then there we have a 3 negative, like that. And let's move on. And we are supposed to find the general solution to that. And this is a quadratic equation in t. So how can we solve that? We can use a general quadratic formula. And we know that the general quadratic formula is equal to a negative b plus or minus the under root of what? The under root of b square minus 4ac over 2a. That is to say, there we are going to have a negative 6 plus or minus of negative of positive 6, that is squared, minus 4, our a is 1 and our c is negative 3 over 2a, our a is 1. That is to say, simplifying that, we are going to be left with negative 6 plus or minus of 36, and that is plus 4 and 3 is 12 divided by 2. That is to say, we are going to be left, and this, remember, is t. We are going to be left with a negative t plus or minus, if you add the 2, it's 48 over 2. And if you try to simplify that, you will find that this is 16 times 3. And if we take 16 times 3, that is to say, we are going to be left with a negative 6 plus or minus 4 comes out of the under root, and 3 remains inside, and then over 2. That is equal to t. That is to say, t equals to what? If you try to simplify that, is 3 plus or minus 2 the under root of 3. And remember that t is equal to tan of in our case there is tan of x over 2. Now putting that in that position, that is to say, we are going to have tan of x over 2 equals to what? Equals to that thing there, negative 3 plus or minus 2 under 3. And remember, once you are trying to solve this by the use of the inverses, we know that the general formula for the inverse of tan is equal to what? Is equal to, it will be what? There we shall use x over 2. It will be equal to what? To 108n plus the tan inverse of the thing here, negative 3 plus or minus the under root of 2 under 3. 2 under 3. Multiplying this to that side, that means we are going to have equals to what? These 2 multiplying to that side, because we've been told to find the general solution. That means the values of x in a general form. That is to say, if multiplying 2 on that side, it will be 218n plus tan inverse of the negative 3 plus or minus 2 under 3. But what is our n? N is equal to 0, 1, 2, 3, and so forth. That is to say, if we put that in a very good manner, that is x equals to 306n plus 2 tan inverse of all of that, that is negative 3 plus or minus 2 under 3. That is how we find the general solution to that. That means that is the general solution to that. And sometimes you can be told to find the in radian form. That means even your angle should be in radian form. And that part, how will it look like? It will be x equals to 2 pi n plus 2 tan, if you can find the value of that. But mind you, there we have plus or minus. So if you can find the value of this, that means first of all you shall use the addition sign, and then the second one you shall use the negative the subtraction sign. But remember, the question asked us to find the general solution. That means there it's enough to leave it like that. Minus 3 plus or minus 2. So this will be in radian form. But remember, even the angle that you will be finding there should be in radians, so that the whole answer should be in radians. And remember, the value of that tan inverse should be in radians. So as if you add the radians and the radians, the whole answers will be in radian form. But that will be in degree form. So that is how we find the general solution of the equation like that. This was in radian form and that was in degree form. Do find other questions that asks you to do the same. We have the sign that asks us to find the general solution, but that is in case of T formula, and we are supposed to use the general solution to find the general solution to that. Let's see the next example. Okay, now find the next example tells us to find the value of x in the equation cos 4x plus 2 sin 4x equals to 1, whereby we've been given the range, whereby 0 is less or equal to x less or equal to 180. That means the values should lie down there from 0 to 180. That means 0 and 180 are also included in there. So let's see how can we find a solution to that. So the equation tells us that we have cos 4x plus 2 sin 4x equals to 1. And remember that we've been told that the angle should lie down there in that range, that is in between the 2, and 0 and 180 are also included. Now let's see how can we do that. Now you can do that question in a lot of ways. In a lot of ways you can expand by the use of compound angle and then use T formula. But also you can do this the following. For example, I let let's say y equals to 4x. That means I'll be left with cos of y plus 2 sine of y equals to 1. But this is possible when the angle there and that angle are the same. That will be possible. But if, let's say, there is 2x and there is 4x, that means you have to expand and get the value of x in terms of cos and sine. Now let's see how can we do this. Remember, we know that cos of y equals to 1 minus t square 1 plus t square, and the sine of y then will be 2t. Remember this because they are very, very useful while doing your mathematics. Now let's go on. Let's plug them there. So we have 1 minus t square 1 plus t square plus 2, the value of sine is 2t 1 plus t square is equal to 1, my dear student. Now let's simplify that. So we are going to have 1 minus t square 1 plus t square plus this times that equals to 4t 1 over 1 plus t square, which equals to 1. But remember, this and that are the same. That means we can just add. Then we are going to have 1 minus t plus 4t over 1 plus t square, which equals to 1. Now let's simplify that more. Let's simplify that once more. Okay. So multiplying this part there, we're going to have 1 minus t square plus 4t, which equals to this, multiplying to that side, equals to what? Equals to 1 plus t square. Now let's collect like terms. You will see that this coming to this side is going to be equal to what? It will be equal to negative. It will be equal to what? So we have a 1 minus t square. This coming to this side, it will be negative t square. Then plus 4t, and that 1 coming to this side will be minus 1, equal to 0. Now let's correct. This and that is, this is positive and that is negative. That means it's 0. And this is negative and that is negative. That means it's negative 2t square. That is 4t equals to 0. And how can we go from there? As you can see, we can simplify. Let's say divide by negative 2 throughout. What are we going to have? That means let's divide there by negative 2, by negative 2, by negative 2. We are going to be left with t square minus 2t equals to 0. And that is a quadratic equation. We can factorize it. How can we do that? Can we factor out t? And if we factor out t, inside we will be left with t minus 2 equals to 0. That is to say, we can say either t is equal to 0 or t minus 2 is equal to 0. And then after that, you can start evaluating one after another. Then you take this one into general formula and that into general formula. That is to say, we know that t is equal to tan of what? Of, in case of our question, we plugged in there, it was y. That is to say, we have a y over 2. But remember that much correct. What is y? Y is 4x. That is to say, our tan now, our t, that is to say, our t now equals what? Tan of 4x divided by 2. That is to say, we are going to be left with a tan of 2x. And this is the value of t. This is the value of t. Now, if that is the value of t, then let's see. By the use of this one, when t equals to 0, we're going to be left with tan of 2x equals to 0. That is to say, when we are trying to look the inverse of that, that means we are going to use the general form. That is to say, we are going to be left with 1/8n plus tan inverse of 0. But remember, this is 2x. Then you are supposed to divide by 2. That is to say, x equals to what? Equals to 180 divided by 2, that is to say x equals to 180 divided by 2, it's 90 degrees plus this divided by 2. And we know that tan inverse of 0 is 0. That means divided by 2 remains to be the same. Now remember, what is n? N is equal to 0, 1, 2, 3, and so forth. Now let's evaluate the value of x now. If we put there 0, that means x, that is, say, when n is equal to 0, it implies that x is equal to, if you multiply by 0 there, is 0 degrees. And when n is equal to 1, it implies that x equals what? To 90. You just multiply your n there. Then when n is equal to 2, it implies that x is equal to 180 degrees. When n is equal to 3, x equals to what? Equals to 270. But remember the range that you were given. You are told that the values of x should range from 0 to 180, and you will see that 270 is out of that range. That means this is not in the set of solution. In case of the first part, that means once we are going to write the set of solution, then 270 we are going to leave it. We are going to leave it. Now let's go to the second part. Remember we said that t is equal to 0 or t is equal to 2. T is equal to 2 to 2. T is equal to 2. And remember we say that either t is equal to 0 or t minus 2 is equal to 0. That is to say, t minus 2 is equal to 0. And then this is t equals to 2. Now let's find the, we know that t is equal to tan of 2x. So it is tan 2x equals to 2. And what next from there? Let's find the inverse to that. And remember, we are supposed to use the general form. So that will be 2x equals to 180n plus tan inverse of 2. But remember, all of this should be divided by 2. That is to say, we have x equals to 180n. And our n, you should define your n, where n is equal to 0, 1, 2, and so forth. That is to say, this is equal to plus tan inverse of 2, and all of that is divided by 2. Now let's see. 180 divided by 2, we know it's 90, but what is tan inverse of 2? Then we have to divide that by 2. Let's see. Let's make good use of our calculators and find the tan inverse of 2. So shift to tan inverse, then 2, and the value is 63.4. So it will be equal to what? Equal to, if you divide that by 2, it is 90n degrees plus 64, the answer that we obtained, divided by 2. So answer divided by 2 equals to 31.7. 31.7. So that is x. Then we are supposed to check for the values when n is equal to those values of n. That is 0, 1, and so forth. Now let's see. So we have x which equals to what? So we have x which equals to 90 degrees n plus 31.7 degrees. You can make good use of your calculator. And how do you write that? We know that we use, it will be 90, then alpha, x, then plus 31.7, or sometimes you can use that tan inverse to do that, so that you cannot you don't miss those decimal points. So let's see. Let's use those decimal points too. That is to say, we are going to be left with tan inverse of 2 was that divided by 2. That was the answer. Then we can say 90 n alpha x plus we have there 31. You can just use the answer. I know you know how to use your calculators. And now when n is equal to 0, we know that x will be 31.7 and the numbers. And now when n is equal to 1, that is to say x equals to what? Let's use our calculator and calculate 1. That is 1. That is 121.7. And when n is equal to 2, it implies that x is equal to 211.7 and the numbers. Now remember the solutions range that we were given. We were told that it should range from 0 to 108. That is to say, if we obtain the number that is greater than 108 or less than 0, that is to say it is out of the solution set that we have been given. That is to say, this we cannot write in a solution set. That is to say, the values of x, collecting them to be equal to what? We have a 0 from that side, we have 0 degrees, and then we have 90, and then we have 180. It is inclusive. But remember, we also have this. So you can write them in arranging form, either descending or ascending, or you can just write them randomly. So we have 0, then we have 31.70 degrees, then we have 90, and again we have 121.7 degrees, and we have 180 degrees. So this is a solution set to the equation that we have been given to find the value of x when we have that equation. So this is how we find it. Remember your solution set. Remember your solution range. Sometimes it can be from either negative 360 up to 360 itself, or sometimes from 0 to 360, or as it was there. So remember that range, so that you cannot waste much more time doing that stuff there. Now I will leave you some few questions for you to practice, but remember, we have a lot of questions out there. So please find books, find past papers, and do those questions, and make sure you get the correct answers and you go in the correct way. So we have a lot of ways to solve these equations of this nature. You can use other formula, you can use whatever, but make sure you get the same or the correct answers. And the questions that I'll be leaving you today, now the questions are very simple. We have the first question that says, use T formula to find the general solution for for these two equations. We have 2 tan x minus cot of x minus 1. But this, remember, is cot. That means it's the inverse, or is the reciprocal of this, the reciprocal of tan. Remember, this cot is the reciprocal of tan. That means you can reciprocate tan and then have the value of the T formula for cot. Then after that, this is another question. That is 3 cos that thing equals to that. That means you can open by the use of the double angle formulas, and then you can open that, or compound angle formulas, and then you can open that, and then find the values of x from any range. Let's say from negative 360 to 360. Find the range. Find the angles as many as you can in radians and in degrees, so that you can practice. And then we have the use of T formula to find the values of x. Also, the value of x can range from different ranges, either from as we did last time in our examples, or in 360, negative 360 to positive 360, or from 0 to 360. So do all of the cases and see how you can do that, how you can perform that. So there is sec of x minus tan of, but sec of x, remember this is a reciprocal of cos. That means you can reciprocate a T formula for cos, and then you can have the value or the T formula for sec. And then there we have cos 2x minus 5 sin x. So you cannot let this to as we did in the last example. That means you have to open that. You have to open that and simplify that to simple angles as x is seen there, so that you can use the T formula. So I hope you will do those questions and practice very, very, very much better. Now, my dear student, let me leave you there for today. I do hope you understand, and it was a good reminder for you to remember some of the places that you try to forget or try to get them wrong once you are trying to do your questions. So please, please, find other questions from your exercise books, from your books, from the books that are out there. Find the questions from the past papers, and I assure you, practice makes perfect. So please stay there very safe, and remember you have the coming examinations that you are supposed to perform that much better. Up to the next time, you are with Mr. Kimati, your advanced mathematics teacher. Bye.